Prove that cosec theta minus cot theta whole square is equals to 1 minus cos theta upon 1 plus cos theta. Students, we are taking this left hand side. So your left hand side is cosec theta minus cot theta whole square. We will convert all the ratios in sine and cos. We will convert this cosec in sine. The value of cosec theta is 1 upon sine theta. The value of cot theta, this is cos theta upon sine theta. We have written here cosec theta equals to 1 upon sine theta and cot theta equals to cos theta upon sine theta. Both the denominators are same, so LCM will be sine theta. In numerator, we will write here 1 minus cos theta upon sine theta whole square. We are taking square of both the terms. 1 minus cos theta whole square upon sine square theta. Students, we know very well that sine square theta plus cos square theta, this is 1. The value of sine square theta, this will be 1 minus cos square theta. So we are putting the value of this sine square theta. Sine square theta, this is 1 minus cos square theta, and numerator 1 minus cos theta whole square. We can write it two times. We can write it 1 minus cos theta, 1 minus cos theta. Now we are applying here a formula. Students, you know a square minus b square, this is a minus b and a plus b. So the value of a square minus b square, this will be a minus b and a plus b. In numerator we have written 1 minus cos theta and 1 plus 1 minus cos theta. 1 minus cos theta, 1 minus cos theta is cancel out. So we will write here 1 minus cos theta upon 1 plus cos theta. This is your right hand side. Prove that cos A upon 1 plus sin A plus 1 plus sin A upon cos A is equals to 2 sec A. Students, we are taking this left hand side. So by left hand side, we are writing cos A upon 1 plus sin A plus 1 plus sin A upon cos A. There are two fractions, so we will take LCM 1 plus sin A into cos A. This will be the LCM. Cos A into cos A, cos square A, 1 plus sin A, 1 plus sin A, this is 1 plus sin A whole square. Now we will apply here identity A plus B whole square. A plus B whole square is A square plus B square plus 2AB. So we are applying here 1 square plus sin square A plus 2 into 1 into sin A. In the denominator 1 plus sin A into cos A. Now we are rearranging all the terms. So we are writing here sin square A plus cos square A. 1 square, this is 1 and this is 2 sin A. Students, you know formula, sin square A plus cos square A is 1. So we are putting the value of this sin square A plus cos square A. Sin square A plus cos square A, this is 1 plus 1 plus 2 sin A. In the denominator 1 plus sin A into cos A. 1 plus 1, this is 2 and this is 2 sin A. In the denominator 1 plus sin A into cos A. In numerator now 2 is common. 2 is common. In bracket we will write 1 plus sin A. In the denominator 1 plus sin A into cos A. These two terms are same. So this term is cancelled out by this term one time. This is 2 into 1 upon cos A. This is sec A. So this is 2 sec A our right hand side. Prove that tan A upon 1 minus cot A plus cot A upon 1 minus tan A is equals to sec A plus tan A. So students, we will take here left hand side. What's your left hand side? Tan A upon 1 minus cot A plus cot A upon 1 minus tan A. We will break all the terms in sin and cos. We know formula tan A, this is sin A upon cos A, and cot A, this is cos A upon sin A. So we will put the value of tan A and cot A. In the place of tan, we will put sin A upon cos A. In the place of cot, we will put cos A upon sin A. In the place of cot, cos upon sin. In the place of tan, sin upon cos. Numerator will be same. In denominator, we will take LCM because there are two terms. So LCM of 1, you can write here 1. You can write here 1. And LCM of 1 and sin A. This will be sin A. This will be sin A minus cos A. Plus LCM of this denominator, LCM of cos A and 1. Cos into 1, this is cos A. Cos A minus sin A. Now you have fraction upon fraction. So we will take reciprocal of this fraction. So you will write here sin A upon cos A into You will take reciprocal, so sin A in numerator and sin A minus cos A in denominator plus cos A over sin A. You will take reciprocal of this fraction, so cos A in the numerator and cos A minus sin A in the denominator. Students, now what will you do? Now what is common? You can see here sin A minus cos A and this is cos minus sin. So we have to make both the terms same. Means you have to write here cos sin A minus cos A in the place of cos minus sin. So what will we do? We will take minus sign common here. If you will take minus sign common here, so this sign will be negative. You can see here minus sin square upon cos A and cos square upon sin A. And again we have two fractions here, sin square A upon cos A minus cos square A upon sin A. How will we solve this part? Because we have two fractions, so we have to take LCM, cos A and sin A. LCM of cos A and sin A will be cos A sin A. We will do multiply. Sin square A into sin A, this is sin cube A. Cos A into cos square A, this is cos cube A. And 1 minus sin, 1 upon sin A minus cos A, we will write like this only. Students, you know identity of A cube minus B cube. So identity of A cube minus B cube is A minus B, A square plus B square plus AB. So we will use here this identity. This is your A, this is your B. A minus B means sin A minus cos A. In second bracket, sin square A plus cos square A plus sin A into cos A. In the denominator, cos A into sin A. Now these two terms are same. Sin A minus cos A, sin A minus cos A is cancelled out. The value of this part, sin square A plus cos square A, this is 1. This is the identity you know very well. Sin square A plus cos square A, this is 1 plus sin A into cos A. In the denominator, we will write here cos A into sin A. Students, in numerator we have two terms, but in denominator we have only one term. So we will divide by this term in both the terms. You can write here 1 upon cos into sin A plus sin A into cos A over cos A into sin A. Means we are dividing these two terms individually. 1 upon cos A, this is sec A, and 1 upon sin, this is cos A plus this 1 we will write. So this is our right hand side. Hence proved. Prove that 1 plus sec A upon sec A is equals to sin square A upon 1 minus cos A. Students, we will solve here both the sides. First of all, we are taking here left hand side. What's our left hand side? 1 plus sec A upon sec A. We will convert this sec in cos. We know कि 1 plus in the place of sec A we can write here 1 upon cos because sec is reciprocal of cos. So in the place of this sec we will write here 1 upon cos A. In the denominator we are putting the value of this sec 1 upon cos A. Now we are taking 1 in the denominator. So LCM of cos A and 1. This will be cos A. Cos A into 1, this will be cos A, and 1 into 1, this will be 1. We will take reciprocal of this fraction. So what is the reciprocal? Cos A upon 1. Now cos A cancel out. So we will get here 1 plus cos A. After solving this left hand side, we are getting here 1 plus cos A. But we are not getting this right hand side. Now we will solve this right hand side. Our right hand side is sin square A upon 1 minus cos A. Now in the place of this sin square A, we will put the value of sin square A. We have one identity, sin square A plus cos square A, this is 1. The value of this sin square A, the value of this sin square A, this will be 1 minus cos square A. So we are putting the value of this sin square A, this is 1 minus cos square A. Denominator will be same. Now we can write here 1 square minus cos square A square minus B square. So this will be A minus B and A plus B. In the denominator 1 minus cos A, 1 minus cos A, 1 minus cos A cancel out. So you get here 1 plus cos A. Correct? Now you can see here left hand side equals to right hand side. Let's prove. Prove that cos A minus sin A plus 1 upon cos A plus sin A minus 1 is equals to cosec A plus cot A. Using identity cosec square A is equals to 1 plus cot square A. Students, we have to use this identity To solve this part, we are taking left hand side of this numerical. By left hand side, we are writing this cos a minus sin a plus 1 upon cos a plus sin a minus 1. Dividing by sin a and cos a. Dividing by sin a in numerator and denominator. Why we are dividing by sin a in the numerator and denominator? Because we have to convert this cos in the terms of cot. We are dividing by sin. So we can write here cos upon sin minus sin upon sin plus 1 upon sin. In the denominator, cos upon sin plus sin upon sin minus 1 upon sin. Students, you know very well cos upon sin is cot A. So in the place of cos upon sin, we can write here cot A. This will be 1. Now plus 1 upon sin A. The reciprocal of sin A will be cos A. The value of cos A upon sin A, this is cot A plus 1 minus 1 upon sin A is cos A. Now what will we do? We will rearrange all the terms. We will write cot A, then plus cos A minus 1. Cot A minus cos A plus 1. Now what will we do? We know identity cosec square A minus cot square A equals to 1. In the place of 1 we can write this value, and in the place of cosec square A minus cot square A we can put 1. Now we are putting cosec square A minus cot square A in the place of this 1. Students, you can see this 1 in the numerator. You will put this value of 1. In the place of 1 we are putting here cosec square A minus cot square A. And other terms we will write like this only, cot A plus cosec A and minus in the place of 1 cosec square A minus cot square A over cot A minus cosec A plus 1. Now we will use here one identity, A square minus B square. A square minus B square will be A minus B, A plus B. So we are putting the value of this cosec square A minus cot square A. This is cosec minus cot and cosec A plus cot A. Students, what is common in these two terms? This is your first term, this is your second term. So cot A plus cosec A, cot A plus cosec A is common in both the terms. Cot A plus cosec A is common. What will we write here in the place of cot A plus cosec A? 1 minus, this term is common, so we will write only cosec A minus cot A. Multiplying by minus inside the bracket. So we will get here 1, then minus cosec A minus minus plus cot A over 1 minus cosec A plus cot A. Actually we are rearranging this denominator, 1 then minus cosec A and then plus cot A. Now these two terms are same, this term is cancelled out by this term. So what will we get here? Cot A plus cosec A. This is your right hand side. Prove that under root 1 plus sin A upon 1 minus sin A is equals to sec A plus tan A. So students, we will take here left hand side. We are writing here by left hand side. We are taking under root 1 plus sin A upon 1 minus sin A. Actually, we have this denominator in square root. So what will we do here? We will take rationalization of the denominator. We have 1 minus sin here, so we will take conjugate, means opposite sign of this sin A. So we will do multiply by 1 plus sin A, 1 plus sin A in the numerator and denominator both. Students, what will we do here? 1 plus sin A, 1 plus sin A, these two are same terms, so we can write here 1 plus sin A whole square. In the denominator, A minus B, A plus B. This will be A square minus B square. We have written here formula A plus B, A minus B, A square minus B square. 1 plus sin A, 1 minus sin A. This will be 1 square minus sin square A. Now we are using identity here, 1 minus sin square A. The value of 1 minus sin square A, this will be cos square A, because you know very well sin square A plus cos square A is equals to 1. So the value of this cos square A, this will be 1 minus sin square A. So we are using the value of this cos square A. Sorry, 1 minus sin square A, this is cos square A. Now what is the square root of 1 plus sin A whole square? The square root of 1 plus sin A whole square is 1 plus sin A. Square root of cos square A is cos A. we will divide these two terms by cos A. We can write here 1 upon cos A means 1 upon cos A plus sine upon cos A. Now 1 upon cos A this is sec A and sine A upon cos A this is tan A. You know very well 1 upon cos this is sec and sine upon cos this is tan. This is your right hand side.